Welcome to our continuing webinar series, The Future of Work, Integrating Emerging and Cross-Cutting Technologies. I'm Mike Lesiecki, your host, and joining us today is Kevin Cooper from the National Electric Vehicle Consortium. So before we invite Kevin onto the stage, let me tell you a little bit about our project that we're working on. This Preparing Technicians for the Future of Work has a number of goals, but let me focus your attention on the first one, to empower community colleges to prepare technicians for the future of work. And the fourth goal, foster implementation of the cross-disciplinary STEM core to maximize its impact on technician education. So that's our focus today. So what's happening in the future of work? Well, all of us know that the nature of work is changing at very fast and unprecedented speeds. Technology advancements, we know all about them: AI, machine learning, Internet of Things, robotics, eliminating some jobs and creating others. And technicians, they sit right at the center of much of this disruption. What can we as educators? Well, we have to keep up. Our students' career paths are going to evolve. So all of these things are swirling, forcing the future upon us. I like this term, future-proofing STEM technicians. In our project, we focused on 3 skill areas. You can see them here on the right of your screen: data knowledge, advanced digital literacy, and business knowledge and processes. By integrating these into a cross-disciplinary approach in technical programs, will help future-proof our technicians. Now, there's a lot of details on these slides, but notice at the top of these 3 buckets, or these 3 columns, there it is again: data knowledge and analysis, advanced digital literacy, and business processes. We'll be addressing several of the topics in these columns today. So that's the prelude to our presentation. Now it's time to introduce our speaker, Kevin Cooper from the National Electric Vehicle Consortium, the NEVC. Welcome, Kevin. You've been involved with technical education for a long time, have an interesting background in engineering and semiconductors. Tell us a little bit about yourself to our audience.
Thank you, Mike, and thank you all for having me today. So I'm Kevin Cooper. I actually have a doctorate in chemical engineering with a specialty in electrochemistry, which comes full circle because I'm working on electric vehicles and batteries again. I spent about a decade in the semiconductor industry as a process engineer, and then spun off a chemical company and developed chemistries for the semiconductor industry. And from there, I owned a small business. And after that, I've been at Indian River State College for about a decade as well, and very heavily involved in the AT community and a lot of energy projects and now electric vehicle projects.
At Indian River, Kevin, what is your title there? Are you a dean? Are you an administrator? How does it work?
I was the senior administrator for many years, and now I focus back on grants again. So
Okay.
this is my career path: the electric vehicle and some mentoring work I do.
Great. Okay, take it away, Kevin.
Thank you, Mike. First, I want to give you a tiny bit of kudos here. So your work that you were doing is very forward thinking. The 2 parts, I mean, you started it 3-4 years ago, and you were very focused on cross-disciplinary, and you were very focused on the business skill 3, as you said, the business knowledge and processes. And that was ahead of its time, and it's showing relevance now in 2 industries. I'm going to be talking about one of them, but the 2 that are going through a once in a century type transition are renewable energy and the automobile industry, or vehicle and general industry. Now, the energy industry is going towards renewables, and automobile and vehicle and general industry is going towards electrification, which has a lot of definitions. Today, we're focused on a lot of those convergences in the electric vehicle industry. And I'm going to go through this slide for a couple minutes, and then I'm going to come back to the slide at the end. And one of the reasons I want to spend some time on the slide is we work with a lot of colleges and universities, 200 plus of them, from this work, the work that Create does, the mentorship work. And every time I bring up EV, presidents, administrators, and most people push me towards the automotive program, which is the automotive maintenance, repair, and operations. That is a field within EV, but there are a lot of fields and a lot of jobs across all the fields. And they all do have some converging skills, but they all have independence. So when you study your ecosystem, your local ecosystem as a community college or university or workforce, really try to identify which area you should start. If they're building a manufacturing facility in your area to make cars, you probably want to focus on mechatronics. We just had the opportunity to tour Tesla's Gigafactory in Austin, Texas, and it could have been making gadgets. They were taking huge cars, and it's so neat to see a huge Model Y picked up by a robot, and within a second, precisely placed within sub-millimeter resolution to be manufactured. But it was entirely mechatronics. The battery and anode part has other parts, but the manufacturing of its car itself is very mechatronic based. And that goes across a lot of these disciplines. We got to understand what the needs are. I'm going to go on to the next one, but I wanted to make sure, Mike, if you had any questions, you just interrupt me when you see fit.
Well, it's interesting because, in today's world, with all the Chip Act and all the focus on semiconductors, if you talk to those workforce people at the companies, what they want is mechatronics. Isn't that interesting? We're talking about cross-disciplinary skills, and you mentioned it, that each of them has their own thing, but they also have at the core many similar things. I think that's fascinating.
One other thing I wanted to point out, just come full circle with what you were saying at the beginning, Mike. When we were at Tesla, one of the things that they wanted every technician to know is the business process and that what is co-located on site. Their margins are all with every technician understanding the full business process. And if they have to do a repair to a robot, they have electricians in shop, they have robotic repair in shop. All their waste stays on site, all gets reprocessed. So they wanted the technicians to know the full cycle. And it's funny because my origins is semiconductor. And the day I was at Motorola Semiconductor, I took a 2-week semiconductor processing course, and every employee took that to understand the full semiconductor process as well.
Right.
Understanding the business knowledge is super important.
It was funny. We were just talking about business knowledge and processes in industry. Factory metrics are important, right? What's driving us? What are our key performance indicators? And they anticipate their technicians to be aware of those things and to participate in that. And yet, sometimes if you go to our college programs, we don't address things like that at all, metrics. So I think there's a lot that we can learn from looking at both sides about seeing a place like that Gigafactory and understanding some of their drivers. Anyhow, we're getting off the topic, so I should let you get back to the presentation.
I'm just going to go through these bins here, but Mike, I just want to reiterate your point. Data literacy and understanding data science is becoming more and more prevalent across all manufacturing realms. And I think there's a lot of AT projects actually focus on, putting, contextual math into the projects.
Okay, good.
So the second bin here is maintenance, repair, and operations. And this bin is what I started talking about, which is repairing of electric vehicles. But as you think about it, and if you're thinking about it holistically, I want you to think about aviation, marine, and automotive. And then there's a huge category that everyone ignores, which is bigger than all them combined, which is the light electric vehicle, and which LEVA for short. And there's actually certifications in that. If you look in the US, there's already something like 170 million light electric vehicles. The definition is rough, but it's normally under 60 volts, which is golf carts, bicycles, scooters, a whole lot of other things. And there's certifications, and they do need a lot of repair. And quite frankly, a lot of the risk in the industry and a lot of the risk that insurers are worried about are in light electric vehicles, because homeowners are trying to repair them and they're not using certified batteries and they're causing fires. You read about this every day. There was a container ship that burnt down. There was an apartment building in New York that burnt down. So I think as a community college, there's certifications that are attainable and are good entry points. A lot of folks should think about adding a light electric vehicle type certification as well. If we go on to emerging technologies, and this is what's interesting on the convergence, and I have a slide coming up on this, I think, is when you talk about EV, you talk about autonomous vehicles as well. So you have to understand the radar, the LiDAR, the optical sensors in a car, and make sure those are aligned and that the technology is there. So there's 4 technologies that emerge into EV. You have the battery technology, you have the automotive technology, you have the autonomous technology, and then EVs actually don't offset carbon footprint any more than regular cars right now if it's not coupled with renewable. So as you build this whole idea of getting more and more EV cars, and all these cars states have standards, it's super important to couple it with renewable, which brings us to the next one. And the next one probably has as many jobs in these 5 bins as the other 4 bins combined, which is the charging and charging infrastructure. And it can go anything from utility scale, where you build fields for fast charging. And that's part of the NEVI money that went out there, the infrastructure money to build the electrification highway. Or it could be local charging inside a house, inside a garage, inside, parking deck. And at the high level, it's really, really similar to the jobs that people that have substations and high voltage training in solar and solar industries and just utility in general. But in the charging garage, it's really just an electrician's helper that's doing the work. And it's another area that a lot of schools can scale up because it's an attainable, easy to get credential to go out and install. And there's just a huge need across here. And I'm going to go more into the convergence on this in the next slide. But the last area I wanted to discuss a little bit is fleet conversions. And, if you look at fleet conversions, it's not obvious what the skill sets you need are, because it is high voltage. It's a lot of economics, like you said in your skill 3, the business knowledge. Is it make sense to convert? What makes sense to convert? Like some things that make sense to convert are like mail trucks, because they brake a lot, and most EVs have regenerative braking. So you're saving a lot of that energy from the braking. When you're converting large fleets like school buses, you got to really look into not just the electric power draw you have, and if there's a supply chain for the equipment you're going to need to install, but these equipment gets really hot. And in the winter, you're going to heat your garages so that it maintains a temperature for charging. And in summer, you're going to have to air condition your garages. It's no longer going to be open air. So you really have to also learn a lot of HVAC skills. Mike, any questions before we go on?
It's a fascinating discussion. I have to admit, you mentioned not many people recognize the light electric vehicle market. I have an electric bike, certainly, and I'm aware of some of the issues that you mentioned about the dangers of fire and things like that for poor charging systems and so on. It seems an area that I haven't really realized there's an opportunity for technicians there.
Yes, Mike, that's correct. And what's nice about that, and just to stay on the slide for 1 second, the light electric vehicle has an industry recognized certification. So there's something that exists that the industry recognizes. And then in maintenance, repair, and operations, there are industry recognized certifications from each of the vendors. Tesla has a certification, Kia, Ford, they all have their own certifications. And then NSF actually funded a couple projects, Ken May's leading one of them, which is the EV Pro Plus, that offers certification in conjunction with the Society of Automotive Engineers. So in that box, there's a lot of industry recognized certifications. Mechatronics has certifications, but in the other bins, infrastructure, charging infrastructure, fleet conversion, we're still kind of in the wild, wild west. And that's one of the things we're working on as a consortium. We're helping create those standards, and we're helping create those certifications so that students don't just come out with the skills, but something industry recognizes.
Sure. Perfect. Let's go forward.
Let's go for it. So I wanted to show this picture, Mike. If you're not familiar with what this picture is, it's seen about on 40% of charging stations across country. And it's kind of a crazy stat. 40% of charging stations are down at any point in time in 2020.
Wow.
Imagine 40% of gas stations shut down, So, and the reasons that they are down are all across the board. But before we really get large adoption of the EV across the whole United States, we had to overcome this charging anxiety that people have, this range anxiety that people have. So properly training people to install charging stations and having certification standards matters. And I want to just take you through an example. If you were to install a charging station at your local grocery store, the first person that comes out does site analysis. And this is the convergence of technologies. They have to look at CAD drawings, understand where the electrical is, where the plumbing is, where the traffic is, everything else. They have to understand CAD. After that, they have to model what it would take, probably in CAD as well, to build the charging station at a certain location and do some business modeling. Does it make sense to run high voltage lines this far? Can we bring it any closer? The next person, once you decide on a location and gotten all the permits, the next person is really an excavator. It's a lot of construction skills they use. They have to dig the ditch and run the lines. It's excavation and conduit. The person after that is a high voltage electrician who installs high voltage lines on this charging station. Now it's electrified. Now you have to network it. So that person needs to know Cat5 cabling, they need to know networking. And last but not least, it has to have an IT interface so you can charge for the charging or have it free or keep track of it. So when you look at the skill a charging technician has, it's CAD, it's high voltage, it's excavation, it's IT, it's networking, and the last element is cyber. So those are this convergence of all these skill sets that fit into a charging installer. And quite frankly, the closest that's out there is someone who's certified in like solar, like NAVCEP certification, because they have the voltage, they have the communications, and they have the excavation portions of it. So
And connectivity too.
The connectivity, yep.
Yep. That's a fascinating example. It covers everything. It's like one of the best examples of cross-disciplinary STEM stuff I've heard. That's really good.
Mike, let me see if you can guess what is the number one reason a charging station is down. It's one of those
internet
parts.
connectivity.
It is. You're right, Mike.
Really? Oh, it was a wild guess.
Yeah, it's the IT world is the main reason they're down. And there's just so many meta interfaces on it. So like so many software updates can have an effect on it because there's no uniform. I think a lot of manufacturers have now switched to Tesla. I think it's up to 12 automotive manufacturers are now switching to the Tesla. So they are standardizing it somewhat, but right now there's a lot of different stations out there. And then the number two reason actually is just the vandalism, that's and one of the challenges different states have is like fast chargers had to have an auto button that you can hit to go off in case it's going to be a fire or anything. People come by and just hit that button a lot. And you can't just have anybody undo that button. You have to actually send out a certified electrician to hit the button. And that is actually why Tesla forms these partnerships with Wawa and BP, because they certify people at the gas stations to go, That's why it's not just standalone charging stations.
Cool.
Next slide.
Oh, I like this.
Yeah, this is probably outdated already. This is from about 6 months ago. So I've never seen anything like this in my professional career before. Working on electric vehicles and renewable. I worked in the nuclear world, and nuclear world had slow growth. I think in the last 2 years in the United States, there's over $100 million going into manufacturing of, electric vehicles. And every place they're building electric vehicles, they need a battery source next door. So, every one of these has a battery place next door to it. And in the battery world, there's batteries for automotive, which are called automotive batteries. And then they also provide batteries for the grid, which are called ES, storage batteries. So most of these spots that are building batteries are doing both actually, which is good for both scenarios. They're building batteries for automotive and they're building batteries for the grid. About 80% automotive, lot higher margins in the automotive battery world is the reason.
Kevin, the term Gigafactory appears several places here. Is that unique to Tesla?
It is unique to Tesla. It's just, I think it's their marketing term. Okay. So, and what's interesting about this is the skill set for a battery manufacturer is much closer to a chem tech than it is to an automotive tech. So if you're building these programs around these spots, and a lot of them are built in the Southeast here, and there are a lot of programs opening in Alabama, Georgia, South Carolina, North Carolina, Tennessee. South Carolina has its own consortium working with a lot of these companies headed by Robert Elliott. And then Clemson's doing a lot of work in the area as well. But they're building mechatronics programs or chem tech programs to help with the battery world. I'll go back to my original statement. A lot of the schools have focused on automotive programs, but they really need to transition into these other areas. In fact, those states that are building them on the right side of the US, those are very late adopting states in terms of adopting EVs themselves. They may be building them, but it's the states on the West Coast, California, Oregon, Washington, that are early adopters of EVs and need more automotive technicians. The other side, they really don't need them yet. So I'm going to come back to this for just 2 more minutes and tell you about a couple of things that are going on that people should be aware of and that are cross-cutting across all of these. And I'm going to just throw some names out there so that people know who to go to. So one thing that is unique, that is really far behind, is there's 800 high school automotive academies, and probably a dozen, maybe 2 dozen have EV resources in them. They're expensive to build, and then they're fairly expensive to transition to EV. And you need different criteria and different, even infrastructure. You need more high voltage, you need more safety, you need a lot of stuff. But there is a school, Weber University out of Utah, got a large grant to convert like 16 high schools in Utah. And they built a really, really good model of what the knowledge, skills, and attributes you need coming out of high school so that you can come into a college academy across a lot of these fields in EV. So The first group I would talk about is the group I'm going in order of from high school through college to forward. So the Utah group has done a fantastic job of helping build the high schools, and it's very systematic. They go in and do an analysis, and then after the analysis, they find the money for the equipment, and they train the faculty at Weber State, and then they launch it. And they've been very successful at scaling this up, and it's a model worth replicating. The other group that you hear all the time, and EVs have become sexier and better, like from an automotive perspective, more people want to work in it because it's high tech, it addresses issues, but it still suffers with diversity issues, and specifically women. There's not a lot of women in the automotive world in general, and Tesla actually even struggles very heavily to get women into their start academies. And I asked them, why do they focus so much on it besides just diversity? And they actually had good data, which I found interesting, that productivity goes up when you have a diverse workforce. People try to, learn from each other in different mindsets and everything else. But they funded a program at a Rio Hondo and John Fralla, where he has whole cohorts of women training to be automotive technicians, and he's been very successful at it. So that's one other model worth copying. Mike, you had something, or you?
Does he use a women-only cohort?
He had both women only, and he has a mixed cohort, but he's been very successful having, a huge ratio of women compared to the national average. He helps others replicate.
I'll make sure we put a link to that in our show notes.
Yeah, please. So I would keep a link to that into Weber State, and then I'm going to jump just to the college programs. I mentioned earlier that Ken Mays has the NevTech program and NevTech Plus now. And what he does is he goes into this time around with his new grant, 15 schools, gives them the equipment and everything to launch to convert their automotive into training on the EV Plus. So in the operations, maintenance, and repair, it's well taken care in automotive. But in aviation, you have NCAT, which is out of you remember where NCAT, Jonathan Beck's center?
In Minnesota, yeah.
It's out of Minnesota. I forget the name of the school. But
Northland Community College.
That's right. That's right. And they're quite leaders in the autonomous world. They have quite a lot of amazing equipment. And because a lot of it is aviation related, they're taking the lead on creating the aviation standards and the aviation maintenance and repair portion of it. And then we are working on some of the marine, because we have quite a number of boat manufacturers interested in, converting and forming EV cars. So in the operation side, you have those. On the manufacturing side, the Manufacturing Center and Karen Birch actually have really good mechatronics curriculum. And then on the manufacturing of batteries, you have Andy McMahon and the Earth Center, who's doing a lot of work, not just on the mining of lithium for the future. They work with several of the mines in North Carolina, like Albemarle, but also on the battery manufacturing, because it's a very heavy environmental process. So you have people addressing all these. And then on the emerging technology side, I'm just trying to make sure everyone's familiar with the resources that are happening and are out there. You have like Natalia and Laser Tech that are doing a lot of modules on the sensors in cars to make them autonomous. And then I want to come back to the cyber side, because John Sands and the NCYTE Center has really, really good curriculum on EV or renewable, both of them in the cyber interface. And every year related to this, they have the cyber across disciplines, where they train folks. People come in to get training, professional development on it. I actually went to it last year, and what they did in the cyber was fantastic. Mike, you have any questions?
Well, John Sands, you mentioned, is coming up in our webinar series, so we'll be hearing more from him. And once again, I'll put links to all of the resources that you just mentioned so that people can access them directly.
One other thing I want to mention there, one of the things interesting about cyber is, because of the supply chain issues we have both in EV and in renewable energy, it's interesting because we're trying to build as fast as humanly possible, but the supplies come in sporadic. So what happens is you design an EV charging station or a renewable or solar field a certain way, but you get whatever parts you can get. And those parts don't communicate well. So then you do like this off-the-shelf fix to it. You just try to figure out how to get them to communicate. But when you do that, you create all these cyber challenges. So thus the need to really teach, you think cyber is such a high level, but it's the communication between pieces that are always the risks in cyber. And you need to teach technicians how to secure those. So it's real. The cyber is a very important topic here.
As we're getting near the end here, I have a question that many of our audience members are thinking about. they're thinking about how do I bring this stuff in, and what their thoughts are is, you mentioned a lot about certificates. Should they think about integrating this into their existing courses? Should they set up a separate standalone certificate program, or should they create a new degree? What advice might you have?
Mike, it's not universal as the answer. It's based upon what your ecosystem needs. I would say the easiest thing to do, and what we're working on the most, is creating a high voltage safety certification that
Oh,
goes across all these disciplines. The commonality across them all is it's all high voltage. It's surprising that an attainable safety certification does not exist. So the
uh-huh.
easiest thing to do would be to work with us and help us embed the high voltage safety certification into your program.
All right.
So
That's a good
that would
starting
be,
point.
yeah, as a starting point. And it's also an exit point. If a student has the high voltage safety certification, they can get an entry level job,
Oh,
you know.
all right,
So the
cool.
only other thing I want to mention here before we go on is Chris McNally in Hudson Valley up in New York is building charging certification for the infrastructure
Oh,
side. So he has a nice NSF grant on that.
all right, good.
That's my last slide. Please scan this QR code. We communicate almost exclusively through LinkedIn. That will let you join our LinkedIn group. And it's, a method of keeping in touch. We have a lot of annual meetings and tours of various facilities, and we can network with you with anyone on the list that I've talked to today.
Well, just perfect presentation in the sense that it really, I think you hit it right from the beginning, right? People think of cars, automotive on the EV, but there's this whole other spectrum from, you mentioned light EV to the blue economy, the marine economy, right? Onto everything else. So I think it's a really good example of how cross-disciplinary skills can actually work in this case. So thank you again for the presentation.
I appreciate it, Mike. Thank you.
Let me wrap up today with a couple of resources that uh, folks can get from preparing technicians, all one word, .org. We have a framework for a cross-disciplinary STEM course, like a white paper, 5 or 6 pages, but it's a good way of grounding yourself in what this is. There are instructional cards that instructors can use exactly in classes. They're short little things that help you do learning activities with your classes. You can listen to our podcasts in this series and share recorded webinars from this series. Oh, here's some of those instructional cards. For example, let's look at the center column, Advanced Digital Literacy. Network communications, you talked about that today. Automation, basic programming skills, network architecture. So these are short activities that can be brought right into the classroom to help people start talking about these things. I mentioned our podcast series. There on the upper left is Technicians in the New Blue Economy, Internet of Things in the center. So you can see a number of podcasts that may spark your interest and help you move forward in your own professional development. And recordings of this webinar series are there. You can see the link, preparingtechnicians.org webinars. You'll find a series, in addition to those recordings, additional professional development resources, instructional resources, and everything to help you future-proof those technicians and bring yourself up to speed as well. Kevin, thank you again. It's just a pleasure working with you. And that's the conclusion of our webinar for today.